person in the lab jumping, and I got data on this particular jumping off the ground. And I apologize if this is you, because I just went in and got this off the computer without asking your consent, so I apologize for that. Coming back down again. And then we want to ask this question about the jump. What's the force on the ground during this following jump? Here's the jump height. There's the depth of the crouch. And this is the person's mass. And this is all estimated from the video. In fact, it looks like his head's gone down by more than 30 centimeters. But the crouch, I'm figuring, is like the center of mass. Like how far is, like, if I was to say that, like the midpoint of his body, how far has that moved down when he's going into the crouch? So he goes into a crouch, pushing upward. At some point, leaves the ground, jumps to a height of 0.5 meters. And then the question is, what is the force on the ground during the following jump?
Like when you start?
During the jump, yeah, during when he's doing this, in the midst of that, hasn't left the ground yet. What's the force on the ground? Now, does this remind you of a problem which you've seen previously? The bush baby problem, the bush baby problem. So remember, for the bush baby problem, we figured out what was the acceleration of the bush baby when it was jumping. So that was our motion part of the story. We got motion. Then we're going to come back here to the force part of the story. And for the motion, remember we did it in two parts? We had the bush baby left the ground, and then the bush baby ended up at the highest point, motionless. What's the direction of the acceleration during this phase of the motion? Down. Oh, as a matter of fact, we know the magnitude of the acceleration during that phase of the motion. What is it? 9.8 meters per second squared. That's just free fall. So in the first phase of the motion, it's just free fall. That's phase number 1. If we know the person's jumped to a height of 0.5 meters, what does that allow us to calculate? The initial velocity. We can calculate how fast is the person moving when the person leaves the ground. That's what we can calculate. If we know that, then we can do the second part of the motion, which is this. The person leaves the ground with a certain speed, certain initial speed. What's the speed at the start? And this is the crouch. This is the crouch. The start of the motion and the deepest part of the crouch. What's the velocity here? 0. And so there's an acceleration. What's the direction of the acceleration? Upward. Acceleration is upward. OK, that's our motion part. And we can go ahead and solve for what that acceleration is. And we'll come back to that. Because I want to now look at the force picture. And we're only looking at part 2. We're only looking at part 2. Okay, while the person's accelerating upwards, while the person's in the crouch, pushing off, what are the forces that act on the person? Normal force and weight. Which is bigger? Normal force. And so there's a force on the ground, or the force from the ground pushing up on the person is bigger than the weight force. What does the problem actually ask for, though? It says, what is the force on the ground during the jump? It's just that it's the same magnitude as the normal force on the person. So we're going to solve for the force on the person, and then we can say that's the same as the force on the ground. How do we know it's the same as the force on the ground? Newton's third law tells us that. So, but we're going to solve for the piece which we can solve for, which is the motion of the person. And when you jump off of something, you exert a force on it. Now, you know that has to be true because it exerts a force on you. So I have a little object here, and this is a little jumping thing. If I put it on the drum head, when it jumps off the drum head, it makes a force on the drum head. It makes a force on the drum head. And I realize this, sometimes, like, you ever had like a little yappy dog like sitting in your lap, and all of a sudden the little yappy dog notices something and launches itself? It hurts. It hurts. Because when you jump, you're exerting a force on the ground. And ultimately, the source of that is because the ground has to be exerting a force on you in order to be able to jump. And those forces have got to be equal, and they have to be opposite. Maybe that one's not going to jump. Once per class, I guess. I guess that made the point. It jumped off the cart.